Now I'm recording this. Okay, so to find the area of the red pathway, we're going to take the area of the green rectangle minus the area of the blue rectangle. So right now we're working on finding the length and the width of our green rectangle. And we just discussed how our width is going to be 41 plus x, which we simplify as 2x plus 41. Now for the blue, now for the length or the width, we would take the length here, 35, plus the length here, x, plus the length here, x. So we'll have 35 plus x on this side, or we'll call that 2x plus 35. So that's just a matter of kind of looking at the picture and reasoning out where each piece of the length is kind of coming from. So the area of the green rectangle is going to be length times width, which is 2x plus 41 times 2x plus 35. But then, as we mentioned before, we're going to have to subtract the area of the blue rectangle, which will be minus length times width, which is 41 times 35. All right, time to simplify. So on these types of problems, I doubt you can just enter your answer like this. I have a feeling that web class is going to want you to simplify these down, and this is going to give us a quadratic when we simplify it. So if we FOIL out the green multiplication, we're going to get 4x squared plus 82x plus 70x plus whatever 41 times 35 is. But we also have this other minus 41 times 35. So whatever this ends up being, it's going to cancel out anyway. And then simplifying by combining our like terms here, we end up with 4x squared plus 152x. So that would be the function once we've simplified it down. And that's your answer for the first part of the question. Then they give us a second question, which hopefully is a softball question. They want to know the area if the pathway is 4 feet wide. Well, all we're doing here is we're plugging 4 in for x, and that's going to simplify down and give us the number 672. And please use your calculators on these. Don't want to do that kind of math by hand. So I'm not going to finish the example out. You'll just take my word for it that it's 672. And let's move on to our next topic. So now we're going to talk about quadratic functions kind of in combination with other quadratic functions. When we have a function, let's say f, and we have a function g, we can add those two things together and combine them to make a whole new function. This example asks us to do that in the first part. So I don't want you to be thrown off when you see something like, I'm going to zoom in so the people in the classroom can see it easier, f of x plus g of x. That is exactly what you think it is. To add these two things together, you just take this plus this. And when we're dealing with addition, you have to remember some addition rules like combining like terms, things like that. So for this question, they want us to add together f plus g, and then they're asking us a very specific question. They're asking us for the degree of the polynomial. So before I even get into any addition, let's talk about what degree means. The degree of a polynomial is the highest exponent, the biggest exponent. So I'll even write that out for us. That's our biggest exponent. So before I even do any work on this, we can actually figure out the answer without even adding anything together. Let's use logic to figure this out. So when we add two polynomials together, we will be combining things that have like terms. Well, but when we do that, let's say we combine something that has an x cubed with something else that has an x cubed, like 2x cubed. Actually, what do we have here? Let's say we would combine the x squared and the minus 3x squared. But when we combine those, all we're doing is we're adding the numbers in the front. So we end up with a negative 2x squared. The exponent doesn't change. So when we add two functions together, our exponents aren't going to change at all. So the answer to what our biggest exponent is, what the degree of the polynomial is going to be the same as whatever we started out with. We started out with a biggest exponent of 6. And when we add all of this together, our biggest exponent will still be 6. So we can answer this question, without even doing any of the calculating. Okay, so this was more of a conceptual question. The next part asks you to, let's start erasing some of this stuff. The next part asks you for a degree in a polynomial that they have you construct from f of x minus 2h of x. So this one we might have to think about a little bit. So h of x is here, and our biggest degree is 3x to the fourth. So 4 would be our degree of this polynomial. Of f, our degree would be x to the fourth from this 6x to the fourth. If we are going to be combining f and h together in this way, though, let's write it out at the bottom. F of x plus 2h of x would be 6x to the fourth minus 3x squared minus 2 minus 2 times, and now h of x is 3x to the fourth plus 2x squared plus 2x plus 3. I'm not going to write all of this out, but I do want to show you what's about to happen here. This 6x to the fourth and this negative 6x to the fourth are going to cancel each other out when we combine these two things together. The negative 3x squared and the negative 4x squared are going to combine together to give us a negative 7x squared. So 2 is now our biggest exponent. The 4's cancel each other out. They go away. Our biggest exponent's now a 2. So that's where we get this. They ask us for domain of all of these functions whenever you're dealing with polynomials. Your domain is always going to be from negative infinity to infinity. The only situations where we have to even consider restricting our domain are when we have a fraction with x's at the bottom, or if we have square roots. That's it. There are some other areas too in like logarithms, natural logs, and things like that, which I don't think that you've dealt with so far this semester in this class, so don't worry about those. The only two areas you need to know to restrict the domain are square roots and fractions with x's in the bottom. So a polynomial that doesn't have any of those things is just going to have a domain of all real numbers. So we've got negative infinity to infinity. Okay, so let's get more specifically into quadratic equations themselves. Quadratic equations are defined as equations with their highest exponent being 2. They are degree 2 polynomials, degree 2 functions. The shape that they come in is of a parabola. So I'm sure you've seen plenty of quadratic equations that look like this. Parabolas facing up. Or maybe something like this, a parabola facing down. We have a different name for those two shapes. A parabola facing up like a bowl, we call that concave up. Think of a cave facing up. Or if it's upside down, if it's been flipped, we call that concave down. So that's like a cave facing down. So the thing that determines whether our parabola is concave up or concave down is whether it has a negative sign in front of it. So if we have something like this, negative x squared plus dot, 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 there could be other things there. But if it starts with a negative x squared, it's going to be concave down. If it starts with a positive x squared and then a bunch of other stuff, it's going to be concave up. So it doesn't necessarily have to look like this either. It could look like a negative out in front of a, say, x plus 1 squared. So the negative can be completely out front of the x squared, or it can be kind of connected to the specific x squared term. But if there's a negative out front, think concave down. Should be pretty easy to remember. So here is a new word that you might not have heard yet this semester, extrema. This word means extreme. It means the point that is the most extreme on your graph. So when we're talking about an extreme point, we're either talking about the extreme top or the extreme bottom. So extrema have other names. We often call them the minimum or the maximum. And whether we're dealing with an extrema, which is a minimum, will depend on whether we're dealing with a concave up or a concave down quadratic. So in the two examples I drew before, you'll see that a concave up parabola has a minimum. A concave down parabola has a maximum. Another word for an extrema, or another word for a min or a max, is vertex. So these are just different names that all mean the same thing. Extrema and vertex are generic. They can refer to a high or a low point, whereas minimum and maximum are specific. They can refer only to a low point or a high point, respectively. Okay, so the word we're going to try to use probably most often in this class is vertex when we're dealing with quadratics, because the vertex is a very special point. So we're still talking about the same point here. The vertex is this red dot that I put on both of these pictures. But there's a nice, neat little formula that can help us find the vertex of a quadratic very easily. So if we have a quadratic that's written in this form, f of x equals ax squared plus bx plus c. In other words, we have it written in descending order. Everything's multiplied out. We don't have any parentheses or anything to deal with. It's just a quadratic like we're used to seeing it. The x value of your vertex is equal to negative b over 2a. So negative b over 2a. In fact, if you all remember your quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, it's actually the quadratic formula minus the discriminant, right? Imagine this weren't here, negative b over 2a. So if you already have the quadratic formula memorized, this should be really easy for you to memorize. Negative b over 2a is the x value of our vertex. So once you know the x value, it's very easy to find the y value of a function because you can just plug it into your equation, find your y, and then you have your vertex point. So let's do an example that shows why we care about something like this in a minute. First, we're going to do example 1. So this came from Homework Common 9A, and it's the very first question on the common homework. If they give us a function, notice this is a quadratic, and they even kind of start to hint to you when you're dealing with quadratics. They'll call them Q. We could just as easily call this f of x. So we've got a quadratic function, and we want to find the extremum value. When you hear extrema or extremum, think vertex when you're talking about a quadratic. So all we have to do is figure out what b and a are, because our extremum value or our vertex is going to be located at the x value of negative b over 2a. Well, if this is b and this is a, then we could just plug in negative b over 2 times a. Simplify this down, 20 over negative 8, negative 5/4. That's where you get your x value of your vertex from that very simple little formula, a quick plug and chug. And then, what did I do wrong? Thank you. Oh, I guess that was still right. 10 over 8, negative 5/4. Don't know what happened there, everybody. I think my brain just snapped for a second, but I'm back. Okay, so we have our x value. Now we need to find our y value. And we do that by taking our function, which is q of x, and we know what the x value is, so we're going to plug that in for x. So negative 5/4 goes in for x. And instead of actually working this out, I'm just going to trust you and your calculator that this ends up being 1/4. So our y value here would be 1/4. The next part of the question asks us conceptually to determine whether this would be a min or a max. And the only thing you have to look at to answer that question is whether there is a leading negative in front of your x squared term. Since this is a negative parabola, it is concave down. Parabolas that are concave down have a maximum. So don't think, oh, it's concave down, that means min, because down means minimum. The two words have the same connotation, down, minimum. I made a connection, there I go. Actually draw it. Draw a concave down parabola or envision one in your head, because this is a little counterintuitive. If you're trying to be too quick with this, you might make a mistake. So concave down is going to have a maximum point, a highest possible point, and that's why we have that as our answer here. From homework 9A common version, question 16 is asking us a very, very similar type of problem. So I'm going to work this one out very quickly because all the steps are the same as the ones we just did. If we want to find the extremum value, aka the vertex of this quadratic, our x is equal to negative b over 2a. I'll try to get this one right. Here's our b and here's our a, so we plug those in, negative 7 over 2 times 2, which will be negative 7 over 4. That's how we got the x value of our vertex. To find the y value, we take our quadratic, q of x equals, and we're in for x, we're going to plug in negative 7 fourths. So 2 times negative 7 over 4 squared plus 7 times negative 7 over 4 minus 5. Calculator time. I'm just going to assume that I did this right the first time through, and that this is what you get when you plug your x value in. Here would be our y value. So again, just to recap, a vertex is a point, right? So you're going to have an x and a y value in your vertex each time. Now, conceptually, they're asking, is this a max or a min? Our leading term is a positive 2. So this is a concave up parabola, and concave up parabolas have a minimum point, so that's where we get this response. This is a pseudo word problem. They're asking us to find the vertex. So note, this is the exact same question we just did. We're finding a vertex, same thing. They're calling it something different, but it means the same point. And they want us to find x and y intercepts. So that'll be a different step we'll do in a minute. So first, for the vertex, we need the x value to be equal to negative b over 2a. Well, here's our b, and here's our a. I'll throw a little 1 there so it's easy to see. We are going to have negative 4 over 2 times negative 1, which is positive 4 over negative 2. That gives us an x value of negative 2. Now to find our y value, we have to take f of x, and we're going to plug in negative 2. So that gives us negative 4 plus 8 plus 5, which simplifies down to 9. So that's our y value here, and we're done with the vertex. They also want us to find the x-intercepts and the y-intercepts. So that might require you to remember back to something that we've learned probably in the past before I was here stepping in. So the way I've always found x-intercepts are, those are the zeros of your function. So think about a parabola that goes through these points. These are called the zeros of your function, and you figure out what those are by letting y be 0. So in order to find the x-intercepts of your function, you let negative x squared minus 4x plus 5 equals 0, and you figure out what x is. And you do that by solving. Usually you can factor, but if you can't factor something, you can always use the quadratic formula. I think we can factor this, but first I'm going to divide both sides by negative 1 just to change my signs. because beginning with a leading negative is not super easy when you're factoring. So I'm going to factor this using the AC method, x, 5, 1, plus, minus. And that's going to give us x plus 5 equals 0, which gives us the 0 of negative 5. And x minus 1 equals 0. Add 1 to both sides, you get x equals 1. So our two zeros are the x values of negative 5 and positive 1. So that's where we get these 2 points, negative 5 comma 0 and 1 comma 0. Now the easiest part actually is probably the y-intercept. So the y-intercept is what you get when x is 0. So if we go back up to our function, all you have to do to find the y-intercept is plug 0 in for x. So if I put a 0 here and here and here, we're just left with a positive 5. So our y-intercept is 0, 5. Very, very simple. So we've talked about some of the features of a quadratic, vertexes or vertices, I suppose. Now we're going to put that in the context of a real world problem where we're throwing a ball into the air. So if we are measuring the height of the ball over time, our x-axis, so to speak, is actually going to be a t-axis now. This is going to represent time. And then our y-axis is going to represent the height of the ball. So if I'm throwing the ball from a height of 0, so from the ground, it's starting at the ground and it's shooting up into the air, its height over time will look like this. And then it's going to kind of reach a peak, and then it's going to start to fall again. And based on the laws of physics, the laws of nature, this will always be a parabola, unless there are other weird forces acting on it. Like if all of a sudden a gust of wind blows it in a weird direction, we're not going to worry about that. We're just going to assume there's no wind resistance or anything like that. Your ball will follow a height pattern that is parabolic, that is a parabola, that is a negative quadratic. And they actually give us a function here, and you'll notice it is a negative quadratic function. It's a negative 16t squared. So we're going to ask some questions about this quadratic. The first one is, the ball reaches a height of 82.5 feet after how many seconds? So this is going to happen twice. So let's say 82 feet is like right here. It's actually 82.5. So let's say 82.5 feet is like right here. It would reach this height at this point and this point, right? It's going to pass through it twice, once on its way up and once on its way down. So we have to figure out what that point is. If h of t is negative 16t squared plus 84t, and we're concerned with when the height is 82.5, what we're going to do is we're going to replace h, we're going to replace the height with 82.5. And then we're going to solve. So in order to solve this for t, we need to get 0 on one side, and then we're going to either factor or use the quadratic formula to solve for t. So I'm going to subtract 16t squared, or I'm going to add 16t squared to both sides, and I'm going to subtract 84t from both sides. So we end up with 16t squared minus 84t plus 82.5 equals 0. And we could try to factor this. I would much rather use the quadratic formula. So this is a job for a calculator. Remember your negative b plus or minus the square root of b squared minus 4ac all over 2a. And these are the zeros of our function, so to speak. I have no idea how much web class wants you to simplify your answers here. This can definitely be simplified beyond what I just wrote as my answer. I don't know how much web class requires you to simplify. You might have to simplify the 1776 inside of the square root. You might have to decompose your fraction because 84 and 32 can simplify, and when the square root simplifies, then that might also simplify. So you might have to simplify this significantly. For the most part, today in our video, I just want to show you conceptually how to solve the problems, and we can worry about simplifying in syntax later. So do the problem that's like this kind of on your own, and if you're having trouble inputting your answer in the right simplified form, that's where I can take a look at what you're typing in and see if we can come up with a more appropriate way depending on how web class thinks, which I am not familiar with yet, but I'm getting there. So that's a problem for a future day that we can figure out together if you need it. So we've got our two answers here, our 84 minus the square root, our 84 plus the square root, and then a couple more questions to answer. Does the ball reach a height of 125 feet? You know what that sounds like? It sounds like they're asking us about a maximum. Does it ever reach a certain point? So if we can figure out what the maximum, what the vertex of this is, if we know the vertex, we can easily answer the question about 125. So we're not going to answer B yet. We are. It's right beneath it. It's still part of B. We're actually going to figure out what the maximum is first. So in order to find the max, we are looking for a vertex, which is an x value of negative b over 2a. Well, this is our b, this is our a, so this would be negative 84 over 2 times negative 16, which is negative 84 over negative 32, and that doesn't evenly divide. Oh, I've got the answer right here. That'll be about 110.25 if I calculated this right yesterday. So that's our x value of our maximum. In order to find our y value or our h value, we will plug in 110.25 into h. And use your calculator. This apparently happens at the point 2.625. Did you get something different?
I got that the first time. Like when I did negative 84 divided by negative 32, I got 2.625.
Oh, that's our x value. I am insane, guys. You're gonna have to watch me. I just had these written in the wrong spots, so.
Okay, I thought I did something wrong. I was like,
No. You're right. So 2.625 seconds would be our x value or our t value. So I was just looking up at the wrong answer when I did this. Well, I don't know how I looked at this and thought it was even remotely reasonable that was 110. Sometimes it's just hard to talk and think at the same time, y'all. So scratch all of this. That doesn't make any sense. When we're going to plug in to find h, we'll plug our t value in, which now is more obvious is about 2.6. So when we plug that in, negative 16, 2.625 squared plus 84 times 2.625. Okay, so you plug these in, they simplify down to something closer to 110, and that's where you get your y value, aka your height value of 110. So this maximum height is 110-ish. So now we know very quickly, very easily, for the first part of this question, no, we're never going to reach a height of 125. Our maximum height is 110. So you kind of had to answer the second part of this question before you can answer the first part of the question. Finally, they want to know when the ball hits the ground. Well, the two moments in time, remember time is this axis here, the two moments in time when our ball is on the ground is right at the start and at the end when it's done flying through the air. So these 2 points represent the moments that the ball is on the ground. If we want to know the answer to this question, we have to find those zeros. So let's go back to our original equation. H of t equals negative 16t squared plus 84t. And we're going to set this equal to 0 because these points are both blank comma 0, and we want to know what they are. So if we set this equal to 0 to figure out what t is, then the easiest way to solve this one is by factoring. So we are going to divide both sides by negative 16. 84 divided by 16 is 5. There we go. And now to factor this, I don't even have to use the AC method. These are two terms that both contain a t, so I can actually pull that t out front, which leaves me inside with a t plus 5. So I'm just factoring out a t. And so my two factors are t equals 0 and t plus 5 equals 0, which are both very easy to solve. We get our two answers, 0 and 5. Guys, I did it again. I had a negative sign issue above. When I divided everything by negative 16, this should have become a minus 5, minus 5, minus 5, positive. Goodness gracious. Today is not my day. So basically you're just finding the zeros of this. We didn't have to factor, we could have also used the quadratic formula, but on a problem like this, I think it's usually easier to factor. And that's where we get, at the moment t equals 5 seconds, that's when our ball is going to hit the ground again. Okay. I think this is our last problem. This is a very wide problem, so I'm going to have to scroll back and forth to get all the text on the screen here. We have a problem from Common Homework 9A, question number 14, that's giving us some information about the effectiveness of a television commercial and how many viewers watch it. Looks like an advertising agency found that the effectiveness, which they're going to call E, is measured on a scale from 0 to 10. Then this formula right here, which they're calling E, this formula is where N is the number of times a viewer watches a given commercial. So I'm going to rewrite this. Actually, we'll just do our work over here. Okay, so that equation represents how many times a viewer watches a given commercial. For a commercial to have maximum effectiveness, a viewer should watch it how many times? So we need to find the maximum effectiveness. That should sound familiar. We've been talking about mins and maxes. So looking at this equation E, notice we have a variable n and an n squared. This is a parabola. It has a degree of 2. Our biggest exponent is 2, so it will be a parabola. Is it a positive parabola, a concave up parabola, or a negative concave down parabola? Well, that depends on our leading term. Now, it's written in the back, so it doesn't look like it's leading, but if we had written this in descending order with our biggest exponent first, this would be in the front. And this is a negative coefficient. So this is a concave down. You don't actually need this for the question, but it helps me conceptually think about what we're dealing with. So this is a concave down parabola, which will have a maximum. So the question itself is asking us to find the maximum, which requires us to find the vertex. So I'm going to rewrite E so that it's in the proper descending order. So that'll be negative 1 over 350 n squared plus 3/5 n. And then just for good measure, I'm going to write 0 there so that it's really easy to see what my A, my B, and my C is. So here's A, here's B. My vertex, my x value of my vertex, or in this case, my n value of my vertex, is equal to negative b over 2a, which is negative 3/5 over 2 times negative 1 over 350. This isn't going to be fun, but we're dealing with this, which we can keep change flip. And then simplify, we get 3 times 70 over 2. So 3 times 35, which is 105. I can't believe I did that right. Okay, so the n value of our vertex is 105. And since they're asking us for how many times they should watch it, well, that's n, because n represents how many times they watch it, whereas E represents the effectiveness of the commercial. So our answer is 105, and I don't think they ask anything else about this question. So, of course, it was a word problem, but it was really just asking for the vertex. You didn't really have to even read most of this problem. You just needed the formula, and you needed to know you were looking for the vertex, and that was about it. Okay, so that concludes this part of the homework that's about quadratics. So, a word to the wise. When you're looking at your own homework 9A personal version, you are going to see a lot of problems about quadratics. But we didn't go over quite a few of the different types today. One of the phrases you're going to see a lot in your homework is the phrase standard form. There's a way we can write quadratics in what's called standard form, and those quadratics will have parentheses in them. So it'll be something like what we talked about with transformation. So it might look like, negative x plus 4 squared minus 3, something like that. Or you might see it written like this, a x plus b squared plus c, where there are just letters there instead of numbers. If you see problems like that in the homework tonight, don't do those yet. We're going to talk about those in a video that I'm posting tomorrow. So do the quadratic problems that you can do based on what we talked about today, but don't worry about anything that uses the phrase standard form or looks like one of the two forms I just drew up on the screen. Okay, so that concludes what we're talking about today. Feel free to use the rest of the class period, which is only like 7 minutes, to work on your homework or to ask me questions if you have any.